Alright, hydrohalogenation reaction. Whenever you hear hydrohalogenation reaction, I need you to think of it as reactions involving hydrogen and any of the halogens, be it chlorine, be it bromine, be it iodine, be it fluorine. This major four. So if you know this, let's get to work. Now, you're given a reaction. I told you hydrohalogenation happens to alkenes. And you give alkenes and alkynes. And any reaction involving alkenes or alkyne, I told you your focus is on the bond, the triple or double bond. That's where you focus. Now you're giving HBr. This is a hydrogen. This is Br, bromine. That means you're talking about hydrohalogenation. Halogen. Now, you come here, check. You see that this is 6 6 is supposed to have 6 is supposed to have 6 hydrogen up, 6 hydrogen down, 1 to the left, right, 1 to the left, which is 12 plus 13 plus 14. But since the hydrogen here is not complete, automatically you know it's an alkane. Once you see this, you don't need to draw this, but I've drawn it so that for the sake of teaching you. So since you know this, you interpret it. Now carry this thing. See this as the same thing as just having it to be like this. Carry it and come here and put. When they say plus this, just carry it and come. Carry it and come here and put. So that this becomes HBr. Now, your method is the same with our previous video, the way I taught you. Break this bond, take it here, and when this bond break, it now stands and you clean it. Then this particular bond here, break it and take it to stand. When it break, it will leave. This is it. This is it. This is what is expected of you. So this is it. Now when you check it, that means that in either ways, this same thing can also happen here. You can also have a situation where you have Br this way, a situation where you have hydrogen this way. It depends. Whichever way, you can have two of these molecules in the same position, the same name, but what matters is that you have this carbon attached to either hydrogen or bromine, the halogen. So this is what the compound should look like. So this is your end product. So 6,6H12 bromine. So it's a bromoalkene. And if we want to name this compound, it's a bromoalkene. If we want to name this compound, we are going to have set C6H12 bromine. If we want to name this compound, we're going to have that this is 1, 2, 3. For this particular one, we are naming this 1, 2, 3. So at position 3, then 3 bromo, then when it's 6 is hex, 3 bromo hexane. Then if it's for this one, we can also have this to be 2 bromo hexane. So the next one is hydration reactions. So any of these reactions can happen to alkene or alkyne. So hydration reaction is a situation where I have C bounded by C bounded by C. I have H, I have H. 1, 2, 3, 4. And I have H. Now in the situation where I have this, I'm being told told that this reacts with water. I told you to see water as HOH and not H2O. Makes it easy for you so you don't get into trouble. Just know it, because when water dissociates, it turns into H plus and OH minus. So just know it. So see it this way. So when you see this, remember I told you that the goal is always to focus on carrying this to attack the bond. It's on the bond, so this will attack the bond. So this will be H and OH. So if it's triple bond, this will go here. This becomes this way. This particular bond will come here, so that you lose this. So whenever you have triple bond reacts with water, hydration, it will lose one bond. So that is why every reaction of alkyne takes it from alkyne to alkene, and every reaction of alkene takes it from alkene to alkane. The focus is on breaking the bond. Breaking the bond. So when I break this bond, I have this, and to name this compound now, I'll have that this is going to be first H. Notice that when we move this, we've cleaned it so that we are now having our results. This is the plus. We made it in such a way that it will be easy for us. So when we are now getting the product, we now have H. Count the H. This is 1, 2, 3, 4. Now 1, 2, 3, 4 for this. 1, 2, 3, 4 for this. 1, 2, 3, and 4 for this particular one. So when you check it, count the H. 1, 2, 3, 4, 5, 6. So 6. How many carbon? 1, 2, 3. C3. C3. And notice that there is O. So this is C3H6O, or you can say C3OH6, but it makes more sense this way. So that is why in some cases you have this as, in general terms, for the sake of chemistry, I'm teaching you with this, but for the sake of chemistry, you know that this is something as C3H5OH. Yes, this is an alcohol. So this is the end product, C3H5OH. This is the end product. So if you count it, you now know. So that's it. And in naming, to name this compound, you have 1, 2, 3. First prop. And this is happening at position 1. Prop 1. Then this is a double bond in plus OL. So it's a hydroxy group. So you can clean this now. It becomes propanol, 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 propanol. So propanol. And this is also the same thing as, if you don't call it propanol, okay, it happened that this, so, or you say propane, it happened at position 2, propane 2, or sorry, it happened at position 2. So this is propane 2, or propane 2, or you can call it 2-hydroxyl propane. 2-hydroxyl propane. You understand?